Hey, welcome to another adventure in old code, the place on the internet where we take a look at old QBasic code we wrote back in the day, and we laugh, we cry, we cringe, but mostly we just hang our heads in shame at what came out of our brains. Today we're going to take a look at something called Descent, and I'm really excited. I have no idea what it is, but there was an old 3D game for DOS, if you recall, called Descent. I think we mostly played Descent 2 when we were young, and it was a very cool game. For the time and for our computer, it was the best thing you could ever run. And yeah, I'm hoping someone tried to recreate that game, and that's what we'll get to look at today. But, you know, who knows? We'll see. So let's open this up. Descent. Oh, I'm fantastically excited. Okay, here we go. Oh. Oh, I hit up. What just happened? Try again. Okay, I hit A, and now there's an 82%. I'm assuming that's my health. I'm assuming these guys are shooting me, and I'm dying, but I can't. I'm trying to hit buttons here. Oh, there we go. It's the numpad. So that tells me this is probably my brother. Yeah. And I'm sure I hit 5. And then I got people shooting me. And then I have to go. And then I hit 5 to blow up that guy. Okay, I hit 4. And this is a loop. I'm not hitting. I just tell it the direction to go to, and I'm dead. All right, let's try one more time and try and kill everyone. Can I? Oh, I can go diagonal. Okay, that's easier. What a slow animation. Okay, so now I hit 7 to go in that direction. I hit 4. I shoot him. I'm still at 100%. That's exciting. Okay. Looks like there's 3 guys left. Got him. And I'm at 82%, so that's good. So the diagonals seem to be the better way to travel because you can travel faster, I assume. So it's probably faster if well, maybe not. If I diagonal my way there. Actually, no. If you're on the same... Yeah, it's better to go straight line than diagonal, of course. Okay, and so I'm done. I killed everyone. I'm at 82%, and I'm done. Cool. All right, well, let's take a look at this. This is pretty awesome. I suspect, again, this is my brother because of the numpad, and I wasn't using the directions with numlock on. I was just simply using the number buttons. So that's what my brother liked to do. Okay. Okay, so declare subship and values QWERTY up as integer. That's really strange. I mean, these are obviously buttons on a keyboard, but anyway. So we have an array of 5 X values and an array of 5 Y values. I'm guessing that's the XY position of each bad guy. And 5 D values. I'm not sure what that is. Bad. So this is a variable to hold a picture, an image, probably the bad guy. FND, XY, XXYY. So this is an inline function, basically. Give me 4 numbers, and which are, it looks like 2 XY coordinates, XY, and the second one is XXYY, and this will take the square root of the sum of the squares. This is simple Pythagoras for you. A squared plus b squared equals c squared. So it will tell you the distance between the 2 points that you give it. And we have a random number generator that we also can use. So we randomize the timer, we go to ship. All right, so this draws the ship, and I'm not, oh wow, palette statement, that's fantastic. Okay, so we do some drawing, we draw some lines, we piece set, and then we call the palette. Interesting. Let's put an end here, and I want to see this thing. So you probably can't even see that. Why can't you even see that? Sorry, I'm just looking at my output here. The problem is I can see it, but I can't see it on my, whoops, my OBS out here. I gotta move that down somehow. Oh gosh, that's a little unfortunate. And they're all hard-coded. So, okay, what I'm gonna do is I'm gonna get rid of these, this end statement. I'll get rid of these palette commands, and then you can see we've got, oh, and you can't see the percentage up there either. Wait a second, something's funky going on. 1 second here. Okay, that's better. Sorry about that, folks. I don't know what was happening. My OBS stuff was all crazy. Okay, let's go back to ship. Okay, so now we're gonna bring in the palettes. Okay, we'll put an end here. There we go. Now you can see that. So that's the ship, and it's got this weird purplish color, and that is the color 5. That 5 is cyan. So we're drawing these lines that are, you know, light brown, gross color. Then we're painting 5 up to 6. So we didn't like that color, and so we're going to change color 6 and color 5, which I guess we can do. The palette statement says, you know, take this color number, which is the brown, and override it. And this is essentially, I think it's your, what's the first number in there? Let's have a look. Palette attribute color 3.2. Using PAL 5, yeah, so it's 60. If you want like just a random color, where you specify blue, green, and red values, this is how you do it. You multiply the blue by 65,536, which is an exact power of 2, and then the green and the red. It's just a way of making an entire number, but you can chop it up into 3 segments. But because your first digits are way more value than your last digits, it's just to place the blue value, green value, red value, and concatenate them all together into one integer. So don't be confused about multiplying it by 65,000. This is simply give me a color that has no blue, has 20 green, and 45 red, which is a brown color, like brown and reddish, gross. And this one is, you know, slightly more red than the brown, and that's how you get that color. That's how you get this brownish color with a slightly darker brown. Like that's all we're doing, is we're specifying exact colors to get two slightly different colors of brown. Okay, that's the ship. La-di-da. Let's do values. What's in values? Quartile. Interesting. So 1, 2, 4, 6, 8, 10, 12, 14, 17, and 20 are all assigned to these variables that are just single letters. Okay, here's what I think is going on. He needed all these values and he didn't know what kind of variables to call them, like what to call the variables, and so he just went across the top of the keyboard just to get, you know, 10 different, is it 10? Yeah, 10 different, 10 unique names. Sure, why not? Single letter names across the top of the keyboard, because that's not confusing. So somewhere we're going to use these values, I guess. Screen 12. Shields spelt wrong. Well, that's okay. So we're at 40. XY is 310, 240. So again, screen 12, we've mentioned this many times, is 640 by 480. So this is dead center on the vertical axis and just barely to the left of center on the horizontal axis. So this is, for all intents and purposes, dead center of the screen. True dead center would be 320. And I suspect that's probably what he wanted to do. I don't know why you would offset center by 10 pixels on purpose. Anyway. Okay, then we got this loop. So this is getting random coordinates for the bad guys. Give me a random X value between 1 and 600. Give me a random Y value between 1 and 400. Assign that to XX1, YY1, and then XX2, YY2. So for any given number between 0 and 5, XX that number, YY that number will be their coordinates. It's interesting he's got 0 to 5. See, I always thought QBasics array indexing started at 1. I guess not. I guess I always just didn't use the 0th element. Most computer languages today, I mean, everyone starts at 0. That's the whole point of an array, is to start at 0. And it has to do with memory addressing and what's easiest for the compiler to do, and to look things up. Because the start of the array, you take the start of the array and then you add to it the element index times the size of the variable. And so if the element index is 0, you're right at the start of the array. Otherwise, you have this chunk of memory that you're not using. But I always thought QBasic was simplifying it for the user because it was basic, right? So interesting. I never used the 0th element, but he looks like he's doing it here. Okay, anyway, alive A is 1. Where did we see? We don't even have alive A. Alive has not been declared an array. That's another thing I learned. You can just use it. Okay. You don't have to declare it. I did not know that. Speed is 0.1. And then we're going to go to the top left of the screen and print 40. for some reason, we're going to print the number 40. What? I didn't see the number 40 printed. Oh, there it is. Okay. Okay. Apparently we're printing 40. I assume 40 wanted, like he wanted to print the shields, but instead he's printing hard-coded value 40. Okay, awesome. Okay, here we have our game loop, obviously, and it's a doozy. Hi. Okay. Come on. Change equals shields. So shield starts out as 40, change is now 40. Fantastic. For each bad guy, if he's still alive, then put him on the screen. Simple enough. Then we're drawing, these are the crosshairs with the little box in the middle. So this first line is the box, and it's a 10 by 10 box right centered on where the center of the screen is. So we use the line command and then the B to make it a box, and then we draw the lines for the crosshair things going to the end of the screen. So new variables, px equals x and py equals y. So this is just a copy of your coordinates where you are. It's interesting. Okay, then we get keyboard input, and if we press the button, then G string equals to C string. Okay. And, oh. So this is not, this in key string statement, this is not in its own do loop. So this is just going to scan. And if it has anything, it will, if you press the button at that particular frame, basically, it'll store it in C string. Otherwise, C string is going to be empty. And so if you press the button, it now goes into G string, which sounds dirty to say, but keep that out of your minds. C string is going to be the button you pushed for only this time through the loop. The G variable is going to be set. So when I hit left or 4, C is going to be 4, G will be set to 4, but the next time through the loop, C is probably going to be empty. But G will remain 4. But now we're doing a select case on C, which is interesting. Because I expect we're going to do all of this, and then we're going to do the same thing with the G. Okay, let's whatever. So if you push the button this time through the loop, we're going to, for each bad guy, oh yeah, of course, because you're moving, right? Your crosshairs are always in the center of the screen, and so it's not you that's moving, it's the bad guys. We got to move the bad guys because we never move relative to ourselves. So if we hit 8, that's up. So we're going to add 1 to the Y values of all the bad guys, and that will make them go down. So when we go up, they go down, and essentially, 9 is up and to the right. So then we've got to make them go down and to the left. So that's what we're doing here. Oh, the Y equals Y minus speed. Interesting. So okay, so speed was 0.1 from up here. We set speed up there at the top there to 0.1. So that's fine. So when we go up, Y equals Y minus speed. We're going up the amount that our speed is. That's curious. What's curious is the bad guys are moving down 1 pixel, and we're moving up whatever's in speed, which is at the moment 0.1. So we're going to move up 10 times slower than the bad guy moves. Now that's okay. Well, let's see if that's okay. We'll keep an eye on that. I want to just remind us that we've taken x and y and we've temporarily put them in px and py. So we're not overwriting these values. I mean, we are, but we've stored them in px and py, and then we change. So that's interesting. So y equals y minus speed. So our xy is changing, and the bad guy's xy is changing whenever we hit buttons, but not the same value, like not by the same amount. Bad guys move by 1, we move by speed. Okay, so that's everything. Now this is if we 5. So we do have a beep here. But beeps, DOSBox doesn't do beeps. Okay. If we hit 5, then we're going to loop through all the Ds. All the Ds. Oh no, we're going to set all the Ds. So the distance of 1 is going to be the distance away we are from the bottom. Interesting. So we feed our xy coordinates, and then we feed the bad guy's xy coordinates, but we tack on 20. And so we're really finding the distance between the center of the screen and the bad guy's bottom right corner. Okay. What in the world is this? D1 is less than D2, and D1 is less than D3, and D1 is less than D4, and D1 is less than D5, then D1 equals minus 5. What? If D1 is less than D2, so if D1 is the smallest, then D1 is minus 5. So D1 is the distance between where you're pointing and the closest bad guy. Basically, we're finding the closest bad guy, and we're setting that distance to minus 5 for some reason. All those distances are going to be positive, but then we're going to find the closest bad guy to where we're aiming, and we're going to set that distance to minus 5. That's what we're doing. I don't know why we're doing that, but that's what we're doing. So that gets sent to minus 5 now. This is why we mostly just hang our heads in shame at what came out of our brains. So we're going to use that minus 5 as a flag. Oh, wow. He just needed to know which one was closest. So we could have set this to whatever we wanted. We could have set this to that as long as we checked for that here in this if statement. This value is meaningless. Just the fact that it's negative means we can isolate it, because it'll only be negative because we set it, because these were calculated as distances. Okay, so if we loop through each bad guy, oh my word, If this bad guy was the closest to us, sorry. Okay. Oh, I just saw what okay, let's continue. I just saw these variable names. Naming things is hard, but man, the stuff that came out of our brain. Okay, I don't understand. I don't understand. Based on this, we're going to draw a bunch of stuff. But all this is the guy who was closest to us when we fired. Oh, I forgot. I missed this line here. If point xy is not equal to 0. Okay. And that makes all the difference. Because I was confused that the one set to -5 is just the guy closest to us. How do we know we even killed anyone? There's a person who's closest to us, even if we didn't shoot at anybody. But it's this if statement here. Now, the point command, it looks at a pixel on the screen and returns the color that it is. So 0 is black. So if the XY coordinate pixel where we're pointed at is not black. And so this is key because the graphics itself is a triangle, right? The bad guy is a triangle. And so, but his box is a rectangle. So there's stuff inside the bad guy's hitbox, basically, that's not part of the bad guy graphically. And so in order to get around that, we check the pixel color, and if it's not black, we know we've hit someone. That's why. That's how we can say, if we hit something, find the closest guy to us, and let's blow him up. All right. So loop through each bad guy. If this is the bad guy that's blowing up, draw a line from XY to 0, 0, color 12. And then draw a line from... What? XY 6... What? 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 All right, so in order, he wanted to color the whole screen red. Okay, so normally you could just do something like this. You know, first of all, you could just paint like the whole thing 12, like paint everything 12, right? If you don't give the paint command a second color, it's just going to paint the whole screen that color. The other thing he could have done was, oh, okay, well, I'm just going to draw a line from 0, 0 to 640, 480, and I'm going to do 12, color 12, and I'm going to make it a box fill. That will fill the entire screen. But no. The thing that we did back in the day was we did things the first way that popped into our heads. So these colons just mean it's a different statement on the same line. So what he's done is oh my word, he's broken up the screens into 4 quadrants. So XY is the middle. So you've got a box from the middle to the top left. Wait a minute, these are just lines. Then you've got a box from the middle to the top right. Then you have a box. No, these are not boxes. These are just lines. Okay. No. He's not filling the screen. Here. Let's put an end here and just see what he's done. So clearly... Oh. Oh man, I'm getting shot at so bad. Okay. That's what he's done. He's drawing these lines. Okay, my bad. That's certainly something that he would have to do. He's drawing 4 line segments. Okay, my bad. That's, ignore me. What do we got here? Wow, this is taking a long time. Okay, dir equals 1 to 25. We're going to draw a circle. Straight centered at where you are. It's going to be increasing in radius from 1 to 25. It's going to be a random color between 1 and 15. So basically a circle of random colors. Gee, what other kind of variable can we come up with? For gunk equals 1 to 5, next gunk. Well, we increase weights. It's an empty for loop. That's just the weight. We're increasing it by 10 because we're on a new computer. Okay, next dir. Now, line XY. Okay, so now we're doing the same thing, drawing the 4 lines again, but we're erasing them just so that those red lines flash on the screen. Then we're painting the screen 15, painting the screen 0. Is that what happened? I can't remember what happens. That's not what happens. Oops. Oh, shoot. Ah. Okay, we're back. Whoops. Okay, so we're draw the lines, wait, paint XY 15. Paint XY 0. Do I have the wrong... Use the optional, which are relative to this. Paint is a numeric expression, that's fine. To paint with, or a string expression that indicates the pattern. Border color and background are in details. I don't understand. This should paint everything the color of 15. It totally does. I see. Wait, do I see? It's supposed to fill the screen, but if the circle itself that it's drawing was 15, yeah, then... Oh, because they're lines. So the circles could be white. I mean, it's random. And then you've got the crosshairs, which are white. And so this must only paint up to border 15 by default. Okay. So I was wrong about that. That's okay. Okay, QWERTY. Yeah, because we need another variable name. So let's just call it QWERTY. 5 to 500, step 5 circle. So we're going to draw more circles. Oh yeah, this is the big blue circle. Draw the circle at the center of the screen with radius 5 to 500. Color it blue, and then erase it. QWERTY -5. 0. Oh, I see. Because here we're going every 5. So it'll be 5, 10, 15. So we draw the circle the big blue circle. And then we erase the previous circle. That's all we're doing. Okay. Okay, for FresNet. Now this is what was the kicker. This is why I went into that laughing fit. FresNet is the last name of the FresNet family, who, if you've watched my videos on my stock simulator game, is a fictional family who my persona as the creator of that game really detests. So, okay, for FresNet, equals 1 to 55. Okay. More variables needed. X equals, so a random coordinate on the screen, on the whole screen, gets set to a random color between 5 and 6. Oh, these are the stars, right? Or whatever's going on. Oh my goodness. Wow, what detail. So there's no random dots on the screen. But when I blow this guy up, there's debris. There's debris on the screen. That's hilarious. All those brown dots. I didn't even notice them before. That's debris. Okay, awesome. Okay, so we put debris on the screen, and then we make this particular bad guy that we blew up not alive anymore. We set him to 0. Oh, the QWERTY, all these values are the speed values. So we can go, okay, so the top row of the keyboard up, yeah, the whole thing is just a speed. So right now I'm going like super slow, but I can hit that. Now, if I change my speed, that's a button press. So I stop, but then I can go. So I have to change my speed and repress the button, but now I'm going super fast. Cool. All right. So we could change our speed. So why he set the values 1 through 20, sort of, but he's dividing it by 10. So he could have just divided these values by 10 and stuck them in here. I mean, I guess he couldn't have used integers then, but still. Okay, so now we've ended select. But now we're going to do all of that with the G variable, and it's all the same. Oh, we're just going to move. Oh, I see. Yeah, we're just going to move, because the G is not what we hit, the button we hit this time. The G is what was the last direction that we hit. And so now we're just going to check for the G. He didn't have to do this. Actually, he should have done this. What he didn't have to do was doing all the direction on the C. The C could have just, up here, he could have just said if C equals 5, then do the shooty thing. Otherwise, check for G and do the movie thing. He could have done that. Okay, now we got bad guys, 1 to 5. If they're alive, then shoots equals FNR 500. Okay. If shoots equals 1. Cool. All right, so basically, every time through the loop, each bad guy has a 1 in 500 chance of shooting you. If he shoots you, we're going to draw a line from him 25 and 20 pixels below, so slightly to the right and down, directly to 310 480. So we're basically going to see the shot coming. I think it's down to the middle of the screen from wherever the bad guy is, but I think it's supposed to simulate us getting shot in the chest. So we color it in 10, which is like a bright green, and then we make it less bright green, and then we make it 0, and then the shields get reduced by a random number between 1 and 15, then we paint the whole screen 4. Here, he did know how to fill the whole screen. And then we paint the whole screen black. So we get a flash of red. And during bed, guys. Well, if you're gonna correct your spelling. Okay, then we're gonna draw the crosshairs again. And then we're gonna check to see if px is not equal to x or py is not equal to y. Then we're gonna change the line. Okay, so because we are increasing your x and y value by a floating point number, basically it's, how much time we gone here? Quite a while, okay. It's not an integer, and when your xy coordinate on the screen has to be an integer. If it's not an integer, I believe QBasic will round it. So you can't use the integer value to increment. You have to use your, you can't use it to increment if your increments are not going to be full integer values. Otherwise, you're going to lose it. Because the integer 5 plus 0.1 is not the integer 5.1. It's the integer 5 still. You have to have a backing variable to hold the floating point value. And then when you write it to translate it into screen coordinates, then it's going to get translated and casted or get its decimals chopped off or something. It's got to be casted into an integer for the screen. So px and py are the values of your coordinate at the beginning of the loop. Then we change them by possible decimal values. And if it's not equal to where you were, so I guess this is if you moved. Never mind. Never mind my whole explanation. This is just checking to see if you moved. If you moved, then draw a line, a little box. Oh, that's all it's doing. It's erasing the old box. So if we didn't have any of this stuff, then we're fine. We can shoot to our heart's content. But once we start moving, see, that's the speed at which we're changing. But look at the bad guys. They're moving so much faster than us. And if I increase my speed, then it's more or less the same. Okay, that's a little crazy. And actually, what was y. So if I made my speed y, that should be, oh my goodness, q. Oh, now I don't even know what I did. I broke it. Anyway, that's just erasing everything. Okay, let's continue. For a equals 1 to 5, so we're again going to look at all the bad guys, and if the bad guy has gone off the, the left edge of the screen, then erase him and make him at the far right of the screen. This just allows the bad guys, to wrap around the screen. That's all we're doing here. Checks for the bounds. So he's decided 2 is the left bound, 599 is the right bound, 0 is the top bound, and 410 is the bottom bound. Beat equals 0. So this is just going to loop through each bad guy. If he's alive, then add 1 to beat. So if you've killed nobody, beat will be 5 at the end of this little loop. But if nobody's alive yet, beat won't ever get added to. Well, you're going to add a sequence of zeros, because alive is 0 when he's dead. So if beat equals 0, then 1 equals 1. So if change is not equal to shields and shields is greater than 1, so if you got shot basically and your shields, the shield value changed, and you still got shields, then print the integer of the shields divided by 40 times 100. So it's just turning your shields out of 40 into a percentage. Excellent. And loop until you win or you're dead. Excellent. And there's nothing hidden over there, nothing hidden over here. So that's a neat little game. I think the issue with the constant flickering see what the issue is. Yeah, no, he's erasing it. He's erasing the lines. Then we go back up to the top of the loop. He's drawing the lines. He's doing everything he can do to make it not flicker. But of course, it's still flickering. It's not something that is really fun to deal with. But at least he's not clearing the screen. Anyway, that was a cool little game. Whoops. There's the little beep. And then the circle. And I guess the more we kill, the more debris will appear on the screen. Whoops. Let's give me a little more speed here. It's probably quicker to wrap around the screen at that point. I win! So that's called Descent, and I think it was an attempt at recreating Descent, the game, the actual real game. A 3D world. Anyway, pretty cool. All right. Yeah. Well, thanks for joining me in this adventure in old code. Have a nice day, and we'll see you next time.